the solar PV thing. So what I will do is I will share a presentation. Who has started the recording? Naresh? Or the students have started?
Yes, sir. Students have started, I think.
Yeah. So what we will do, have you all seen the post for this particular experiment? Naresh had made a post. Have you gone through that?
So you're talking about the video, right?
Yeah. So what I will do, for set B, there are 3 experiments, right? One is on the solar PV, the other one is on the 2 experiments are from high voltage lab. So there were some videos made last year when it was done on the online mode. I am sharing them with you, and using those videos together with what we discussed today, you will be given an assignment based on which you can submit the report. Is it clear?
Okay, sir.
Yes, sir.
Yes, sir.
Have you all, anybody seen the videos? The whole issue is if I play the video now, you will not hear the recording. You will only see the video. You understand?
Yes, sir.
So what I will do, I will it appears, has anybody seen and come by any chance? See, these are, yeah. Somebody is trying to say something. Yeah, Vishar.
Yes, sir. So I wasn't trying to say something.
Huh?
Sir, I wasn't saying something.
You haven't seen.
Or someone is spotlighting me.
Yes, sir. So like I was also removed from the meeting like earlier. Can you like make everyone attendee?
No, I.
Yes, sir. People are removing.
People are.
Sir, people are removing me from the meeting. Can you please make us all attendees?
Who has removed you from the meeting?
I don't
Okay.
know, sir.
Okay. Now, Naresh, can you make all these people attendees rather than
Participants.
yeah, participants, not members? They are able to remove somebody else. Okay. So at the one point there were 91 people. Now it's come down to 83. What's happening? Now 81, 80.
It's 92 actually.
Huh? 82. Okay, fine.
The 92.
92. Okay, fine. 92 is the class strength. Okay, I'll share my screen. So this is the experiment which we are looking at today. This is a study of a solar PV panel. So this is what we call as a panel. It consists of number of cells which are connected in series, and then they form a module. What you are seeing here is a module, and the number of modules are connected in series, and that is how a panel is being formed. Now, this presentation which we are discussing today is a supplement to the video which is already posted. And in this presentation, what is expected in terms of a report at the end of the 1 week is mentioned. Okay, this is experiment. Actually, earlier it was experiment 5. Now it is experiment 4. That is one correction. And this is from the energy lab. If you see the video, it shows the demonstration, and there are some data collected from the lab that is included in the experiment. Okay, so now if you look at this presentation has following. It has the resources, introduction. So I'm not going to keep you tied down for the full 3 hours. Basically, it is after working hours. So we'll just have a short presentation, and you will get to look at this video, which is at your convenience, and before the next week you can submit the report. Is that okay?
Yes, sir.
Yes, sir. Yes, sir. Perfect.
Could you, I mean, what did you do in set A? The similar thing was done, right?
Yes, sir.
Yes, sir.
So coming to the flow, we have the resources. There are certain YouTube videos available in NPTEL, which we talked about the solar photovoltaic cells and technologies. Then we'll have a small introduction, followed by various technologies. That will act as a preamble. From there, then we take up the motivation and objective of this experiment. And take a look at the experimental setup and try to see various cases. And these experiments have been carried out in the lab, and some data has been collected. So you will be using that data available in this. Naresh, you have this presentation with you, right?
Sir, this PPT is not with me, sir. Actually, I got some other PPT.
Is it the same thing?
No, sir, this is different. This PPT is the same in the video of that PB Bajpayee sir video. But this
Okay.
PPT is not.
We'll upload this or PPT also after the class. In the then we also mention about the way report has to be given. So coming to the resources, as I was telling you, there are two sets of NPTEL lectures which can be got from YouTube. You can watch them. And there is this is by one Professor Banerjee. There is a book also by Professor Banerjee, which will tell about the various materials that are used in photovoltaic technology and how their electrical characteristics are obtained. So this is about the resources, right? Having said this, we move to the whole idea comes from the fact you all know that energy is very important, and electrical energy in electrical form is the most used energy, and solar PV technology is one way of doing it. And as you can see, this is a graph which shows as of 2019 the global solar power capacity versus Indian solar power capacity. As of 2020, you see this 627 gigawatts. So if you see, the capacity of solar power in India is around 38.2 gigawatts as of 2020. Now, if you look at the price, solar energy is coming at a price of about ₹2 per kilowatt hour, while the Indian non-renewable electricity, the traditional electricity, this may not be the price you pay as an individual customer. It is the bulk purchase price, which is around 3.6 rupees per kilowatt hour. Okay, so all this apart, being clean, renewable, and necessity of the energy, all this brings in the importance of solar photovoltaic technology. And since we are harnessing it as electrical energy, is important for any electrical device, we try to characterize using IV characteristics, right? IV or VI, voltage current plots. You remember the current source and voltage source, which you have representations. So these are the two important characteristics. Now, this slide here shows solar cells. You must be seeing a lot of panels all around. There are three generations as far as solar cells go. First generation, they are based on the silicon wafer, and they are termed as two categories are available. One, monocrystalline, other is polycrystalline. Among the two, polycrystalline is more often used because it's relatively economic. Growing a crystal can be expensive, therefore it is more expensive. A second generation are thin film based. So please watch the video. The video has supplements whatever I am talking here and showing in the amorphous silicon thin film solar cells are there. Cadmium tellurium thin film solar cells. These are the second generation thin film. There is a third generation which is coming up, they are in the more in the R&D stage. That is based on the nanocrystals or polymer-based solar cells and dye-sensitized solar cells or perovskite-based solar cells, and these are also called as concentrated solar cells. So in effect, we have 3 generations. First generation, which is basically based on silicon wafer. Second generation, which is based on thin film. And the new upcoming generation, which is emerging technologies, which also includes some polymer-based solar cells. Okay, so let's see what is it. If this is a solar panel, harnessing the sunlight depends on knowing the certain geometric angles associated with the movement of Earth around sun. So there are there are large number of angles which are specified, but 2 angles which make very important is the orientation of sun with respect to the zenith, which is called the zenith angle, and the remember this zenith is perpendicular to the roof or the surface of the earth. Okay, so you see the directions are marked there, north, south. Then you have the azimuth angle, that is the way your panel is located. You have an azimuth angle and a tilt angle. Tilt angle is in the vertical plane. Tilt angle is in the vertical plane between these 2. It's in the vertical plane. Okay. So these are the crucial angles which need to be considered. And in fact, if you see the video, we have different ways of placing these panels. They are called fixed tilt angle, dual axis tilt angle, and continuous tracking. So all these 3 techniques have been used in our institute, especially in the School of Energy Science and Engineering on top of the rooftop. Now, this particular slide shows the working of a solar PV principle. This is basically a cell. You see, this is how sunlight is coming. To avoid the reflection, there is an anti-reflection coating on top, below which there is a silicon N-type material and then a P-type material, and there is a back electrode. When you connect the 2 on impingement of the light, it gives rise to a electricity generation. So in principle, it appears more by virtue of release of electrons due to the photons. Therefore, oftentimes it is modeled as a current source. There is a current source. And what we find is that depending on the load impedance, the terminal potential varies. And this, we always represent by having a source impedance or source resistance that is shown by a series resistance. And there is some leakage, even though the load is not connected. Some electrons leak from one end to the other. And that is shown by a shunt resistance. Now, even when there is no sunlight, there can be some flow of charges, and that is could be the other way around. And therefore, to indicate that, now if ideally you see if there is no load, what do? You cannot have a current source interrupted. So you try to show it. So now if P is the power that is obtained from this cell, the expression for the current I is given by this expression, where there is what is called as a diode ideality factor, thermal voltage, photovoltaic current, diode current, shunt current, reverse saturation current, cell output current, shunt resistance. So this model will be necessary. This is considered as a standard model taken from the books. In your experiment, based on the measured data, you will be calculating these constants. Am I clear?
Yes, sir.
Yes, sir.
That okay? So this was the brief introduction to the technology and the necessity of a solar PV, the type of resources you have, and the functioning of a solar cell. Having said that, let us look at our experimental goals. We're trying to understand how a solar PV energy conversion system works, and we will familiarize ourselves with the experimental setup. We understand the procedure for measurement. I hope there was a link to the departmental website for an instruction manual. Has anybody seen that?
Yes, sir. But in the instruction manual, like the theories are not mentioned actually. Only the procedures are.
A procedure will be mentioned. Always in
yes.
the instruction manual, theory will not be there. Theory is being given to you here. Okay, you are
Yes,
given
yes.
the resources, so you can and carry out the experiment under different cases. The 3 different studies are conducted. 1, by varying the load. 2, by varying the intensity of light. 3 is the behavior of the solar cell under dark conditions. Is it okay? So the experimental setup looks somewhat like this. You have a rheostat, which basically acts as a load. You have 2 switches. This switch can simulate a short circuit. This switch can simulate open circuit. Right? S1 to simulate open circuit. So you have single phase AC supply, manual switches. There are bulbs. What is this? This is called solar emulator. This emulator basically emulates the sun. It throws light of different intensities on the photovoltaic panel. So this acts as a solar energy conversion system. This is your measurement system where you are measuring. You have switches, ammeter, voltmeter, and you have a module which is rated for 21 volts as the open circuit voltage, 2.4 amperes as a short circuit. So making a small correction here, it should be 0 to 3 amperes, not 0 to 2 amperes. And This is a single phase AC source which takes care of all. Now, since there is associated heat, you find a fan which is placed to cool it. Any issues at this point of time? Okay. So from there, this is how it looks in the lab. This is your ammeter. Rheostat is used as a voltmeter. There is here a DMM has been used, that is a digital multimeter, which is used for measuring voltage. This is the solar photovoltaic energy conversion system. You have the panel or module, and these are the lights. You can see the fans located here. The fan is located here. Solar emulator. PV panel is here. Cooling fan is here. There's a DC power supply, which basically we'll be using. Here, you do find a lux meter. What does a lux meter measure?
Light intensity.
Light output it measures. So solar insolation is measured using lux meter. So this is done, and basically this helps you in locating the, okay. Now, what you see in this slide is a typical lamp. It's an ultraviolet lamp which is used for artificial insolation. So it's rated for 230 volts and draws about 1.5 amperes and a 300 watt lamp. So there are various radiated power is around 13.6 watts. These are two different types of lamps, UVA and UVB. These are from Philips. So they are basically categorized and shown. Okay. Now, there is what is called as a dark test. Dark test is the panel is covered with cloth. We have shown in the equivalent circuit the diode in the reverse direction. To get the specification of the diode, it would be necessary to calculate dark characteristics. So there is this is the panel. It is covered with a cloth. Using a regulated DC power supply, you determine the voltage current characteristics. That will tell us what are the dark characteristics. So when there is no light, what kind of a electron flow can be there if you apply? So you get the diode nature of the cell. You get the diode equivalent of the cell. Okay, so this is what is done with the dark test. Dark test is shown here. You are covering the module. You have a DC power supply and you connect it to the what is covered with the solar PV? Covered solar PV panel. And this is connected to the PV panel, a regulated DC power supply. You know, DC power supplies you have used in the lab to make the measurements. So actually this particular video, it refers to some videos which were earlier loaded in the Moodle, but they are shown as a part of the main video. I would urge you to see those videos. It will tell you how the experiment is performed. Okay? Is it okay?
Yes, sir.
there are two cases. Load, first case is load, and from there itself you can look at the insulation thing also. Second one is dark test. Okay, there are two videos. You can see them in the main video, which is already shared with you. Case one video, and when you do the test with the load variation, how do you vary the load? Actually, here insulation is varied, not the load. Just please just look at this. This is insulation is varied for how many bulbs? 4 bulbs. The light output is given here. This heading you make a correction. It is the insulation variation. Okay. So 4 lamps, 10 lamps, 12 lamps, 16 lamps. Is that okay? So you see how the light output is varying. This is in tens of thousands of lux. Then for different values, as the load is varied, you can see the voltage and the current. How does this current variation come? By varying the load resistance. That is how this becomes. So what has been done is, although we are calling them as load variation and dark test, we are doing for load test as a insulation as a parameter. So you can see more or less the open circuit voltage is similar as the number of lamps are 18.4, 18.2, 18.4. It doesn't really change much with the number of lamps. Short circuit current does change. Short circuit current is this, which depending on the number of lamps is differing. One observation which you should make is you find that in this table there are some VM and IM. They correspond to, so what you will do now with this data, you also plot PV characteristics, power versus voltage and power versus current. Okay, you will find that this VM and IM correspond to the maximum power point, where the power is maximum. See, initially the power is low, it increases, reaches a maximum, again comes back to 0. Starts with a 0 and goes to a 0 again, as the voltage becomes 0. Is that okay? Do you observe that? Are you able to see the screen?
Yes, sir.
Yes. So these plots, when they are drawn, they look like this. 4 bulbs, 16 bulbs, 10 bulbs, 12 bulbs, and 4 bulbs. The other thing is, as a function of the voltage, maximum power is shown here. It goes on increasing. So this is what you are going to observe. And this, of course, is shown as a function of insulation. You can draw for a particular insulation PV curve. Am I clear?
Sir?
Yeah.
Sir, during the dark test, like, are we varying the load? Like, how are we taking the reading? Can you explain that?
This is dark phase has not been done here as it. We're doing only the insulation case, na?
Okay, sir.
Okay. We'll come to the dark phase later. So this is the second case. You will see this. What is done? You vary the applied voltage, measure the current. So it is as though it follows a diode characteristics. Okay, this is the dark characteristics. Is that clear? And if you read the literature, what it says, this behaves like a negative diode characteristics. You saw the diode is placed in the reverse direction in the equivalent circuit. Do you recall that? Yeah, here. You see it is placed this way. Okay. So dark characteristics gives you the value of that diode. So you can see all the characteristics are put here. Okay. Now you saw there is a factor defined for a solar panel called fill factor. Fill factor is, see, the maximum power that is possible if you consider the short circuit current and the open circuit voltage should be VOC and ISC. But what is maximum? Actual maximum is VM into IM. That becomes your PM. So the ratio of this is termed as fill factor. How am I going to find the series resistance? Series resistance will be slope at short circuit current. Okay. How do you say that? P is equal to I plus R. Okay. V naught, V open circuit plus minus IR. Okay. So if you do that, you'll see that R series can be got as a slope from this. Similarly, R shunt will be the slope at open circuit voltage. So what you will do, you can calculate R series and R shunt for each of these and the fill factor. Now, fill factor is not the efficiency. Efficiency is the output power to the input power as we normally define. Okay, fill factor is not the, the efficiency, remember that. So what do? You have calculated the PV panel characteristics for various insulations. You got the trajectory of maximum power point, dark test. This, in effect, you have studied varying the load in different intensity of light and in zero intensity of light. So what are you going to do? You're going to, when you write the report, you're going to discuss this. What is the impact of band gap energy on the efficiency of a solar PV cell. You draw the equivalent circuit for a solar PV cell with equation for current and voltage. Explain all four components. What is fill factor? How is fill factor different from efficiency? Now, if you read and listen to the other video, you will understand the ambient temperature has an effect. And it has an effect on the solar insulation. And you can draw and explain with IV curves. There are two terms used, bypass diode and blocking diode. What is the blocking diode? Blocking diode will never allow any current to flow from the panel. Bypass diode is to, in a set of a series of cells, one cell is allowed to bypass the thing. Okay. So you write the objectives, draw a sketch of the experimental setup and experimental cases and results and discussion questions. Okay. Handwritten reports and plots. One single file with name, experiment number, not on Moodle. Naresh will create on Teams. Naresh, we are taking it on Teams now.
Yes, sir. Yes, sir. I will create one assignment in Teams. Sir, can you hear me?
Huh?
Yes, sir. I will create assignment in Teams only. So I'm allowing students to submit in Teams.
Yeah. So we'll upload this. I'll upload this also on the file section there. Okay.
Okay, sir.
So what about the class? Can I stop sharing? Or I've already stopped sharing?
Sir, for doing the experiment, like, will be provided some MATLAB or Simulink file or like.
No, you're not going to. This is a demonstration based experiment. So you'll watch the video and use the data that is available there.
Okay, sir. Okay.
Sir, here it is written that the plots need to be made with black pen. So we'll use a graph paper or without graph paper.
Yeah, you can use graph paper.
Okay, sir.
So, like, can we plot these things in like Excel or MATLAB? Like,
You can do it. You can do it. You can do it, but you have to embed it again. See, the prior point, it has been asked to plot in this thing is that so that you don't just copy, transfer the electronic file from one student to other.
Sir, so the report will be handwritten, but the graphs we can plot on Python or Excel and then put it in a PDF file.
Yeah, you put it. But the problem, that's what I
Thank you,
said,
sir.
if you can draw with your own hand, it will be good. Okay. Fine. Anything else? So next week we'll meet again. Next week we'll meet for the high voltage experiments. There are 3 TAs. Mr. Saurabh Mitra will be there for the next experiment.
Yes, sir.
High voltage
Excuse me,
again
sir.
is a, yeah.
Sir,
Samar
like
Prakash.
you just said that handwritten is preferred. So will there be any different marking if we make on Excel or if we make like handwritten graph? Hello.
There can be. Naresh, if they give Excel file, are we going to give different marks?
So we'll not give the Excel file. Like we will take the screenshot of the graph which we got on Excel, and then we'll put it, and then we will put it on the report which we are writing.
I know that's what you meant. Okay.
Sir, I think no, sir.
Okay. No problem.
Sir, so
Okay,
we
sir.
can put the graphs, digital graphs as well, right?
Yeah.
Okay. Thank you, sir.
Sir, one more thing, please mention that the submission of report is only 1 month, sir, 1 week. Next Monday it will close.
Okay.
So the submission of reports only 1 week time. Before 1 week, everyone have to submit. After
Naresh,
that,
you
we
want to
will-
say something to the students?
No, sir. Means I want to say that time.
I'm leaving. If you want, you can stay on and discuss with the students.
Sir, I had a few doubts in the experiment.
Yeah.
Sir, like, why are we using UV for insolation? Like, I read somewhere that like solar panels are designed to like work best at like in the yellow light range, because like the spectrum of the sun in yellow light there is maximum amount of energy.
See, this particular emulator, which is used in the lab, is having UV lights.
Yeah, so like, is it like different from the commercially available solar panels?
Yeah, it is commercially available.
And sir, why are we performing the dark test? Like, what is its practical use?
You see, practical idea is you have seen the equivalent circuit.
Yes, sir.
What are there in the equivalent circuit?
Sir, I have to look at it once.
There is a anti-parallel diode,
Hmm.
right?
Yes, sir.
You need to get the characteristics of the diode.
So, like, how
So
how
like
does
when
it
we'll
help?
be doing yes, so like I wanted to say something. So like during the dark test, when we'll be like covering the solar panels, in that like at that time in the equivalent circuit, the current source will be like open circuited, right? It will be zero because like there is no.
Arpan, what are you saying?
So yes, sir. I'm saying that when we will be doing the dark test, like at that time in the equivalent circuit, will the current source be open? Like because there is no output from the solar cell, so that's why
Yeah.
we'll get the.
Yeah, that's going to be open. But basically see, the current source doesn't arise because there is no light falling on the PV panel. That's why you are giving a external voltage and trying to measure those characteristics of the cell. See, cell is like a diode. So your basic cell characteristics you are trying to get. You get the point?
Yes, sir.
You watch the video also, some more clarification will come. Okay. So
Sir,
I'm
regarding
leaving the meeting. Yeah.
Yes, sir. I wanted to ask Naresh, sir, that regarding the deadline, sir, last like previously we used to get till 5:30 on Monday. So will it be the same?
Yeah. Naresh, keep it for 5:30 on Monday.
Yes, sir.
Sir, can you extend it further? Like, because we will be having 2 experiments this week. So it will be difficult for us. We will be having 2 experiments of power system this week. Like on Wednesday also we are having an experiment. So it will be difficult for us to. We will be having an experiment on Wednesday also, sir. Part
Like
C. So if you
yes,
could extend the
and
deadline
we
up
have
to
already.
Wednesday.
This is a very simple report.
Nonetheless, sir, it is quite hectic for us to submit 2 reports, and also we are having a parallel lab for electrical machines. So, if you
Okay,
could
make it
extend
10
to
days,
business-
Naresh.
Okay,
Yes,
sir.
Okay.
Yes, sir. Thank you, sir.
Okay, then. Thank you for coming at the off regular time.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Okay. Bye-bye.
Thank you, sir.
Thank you, sir.
Okay, bye-bye.
So can you please stop the recording?
I will stop recording.